All right. So down at the bottom, there are some important steps down here. Okay. You can see that we always want to do step 1 and 2 using the distributive property to get rid of any parentheses and combining like terms. Those 2 steps are what we called, or what we referred to last time as same side simplify. Right? Those 2 steps are what we refer to as same side simplify. Because those are the 2 steps that we are doing stuff on the same sides. Once we get done with those 2, then we move on to solving. So we collect the variables to one side, we collect the numbers to the other side. That's all of my opposite operation stuff. Okay, that's all of my opposite side, opposite operation. So always start with same side simplify. Get rid of parentheses, combine like terms, and then starting with step 3, you collect all your variables to one side. It doesn't matter which side, but whichever side you take variables to, you got to take your numbers to the opposite side and then go from there. Okay? All right, let's look at some examples on the next page. Okay. Since we did one that was pretty similar to 1 and 2, let's just jump straight to 3. Okay, because we all love fractions, right?
Yeah, we do.
It's not really that scary. Okay, so remember, anytime I'm doing a fraction times a whole number, it's multiply the tops, divide by the bottom. So multiply, so somebody grab your calculator, make sure it's handy. So we have 3 times 48. So what's 3 times 48? 144. Okay, so then we have 144 and divide by the bottom. So what's 144 divided by 4? 36, yep. Okay, so that piece is 36. See, it wasn't that bad. Now let's do the same thing with the 16. 3 times negative 16 would be negative 48, right? And then divide by 4 would be negative 12. So minus 12x equals, and then the other side should be cake, right? 4 times 4 is 16. 4 times 2x is plus 8x. So I've distributed. Is there any other same side simplify I can do? No. There are no like terms I can combine that are on the same side of the equal sign, right? So now my variables are on opposite sides. I personally like to keep variables positive. Okay? You don't have to follow that same thing if you don't want to. But I personally like to keep variables positive. In order to keep my variables positive, it would be smarter for me to add 12 to both sides. Okay? So I'm going to add the 12x to both sides. And again, if you wanted to take all the variables to the left, you're more than welcome to do that. So I'm left with 36 equals 16. 8x and 12x makes plus 20x. Whichever side I take variables to, I have to take numbers to the opposite side. So I'm going to subtract 16. If you did it the opposite way, that's fine. So I get 20 equals 20x. I divide, and I get x is 1. And regardless of which side you take variables to, guys, and numbers to, you're obviously going to get the same answer, right? The answer is the answer is the answer. That doesn't change based on the order in which you solve it. Okay? Okay, so just like we talked about earlier when we were talking about the rubric, remember 3 was mastery. Mastery means I can do it independently with very little prompting from a teacher or peer, and I make few mistakes. That's a 3. A 2 would be near mastery. So near mastery means that you may need a little bit of prompting from a teacher or peers. You may make some mistakes as you're doing this, but you can mostly do it independently and you're really close to mastery. That would be near mastery. That's a 2. A 1 is needs improvement. So you have the basic concept of what's going on, but you need some help getting through the problems from either a peer or a teacher. You may make several mistakes as you're going through it, which is not a bad thing, right? But that's where a lot of us are in the beginning stages of learning something, and that's okay. So a 3 is mastery, 2 is near mastery, 1 is needs improvement. A 0 means you have no idea what's going on. On any kind of assessment, if you're ever marked as a 0, that means you either left it blank or you completely wrote stuff that makes no sense towards the problem. Okay, so 3 is mastery, 2 is near mastery, 1 is needs improvement, 0 is no evidence. Okay, so several times while we're doing lessons, I will ask you guys for a comfort level. Okay, and a comfort level is very simple. You're going to hold up however many fingers you feel like you are. So if you feel like you have mastered the topic, you're going to hold up 3 fingers. If you feel like you're near mastery, you're going to hold up 2 fingers. If you feel like you need some improvement, so you have the basic concept, but you still need some practice, you still may need a little bit of coaching from peers or a teacher, you would hold up a 1 finger. If you have no clue what I'm talking about, you would hold up 0 fingers. Okay, and it's not like a loud and proud, you got to tell everybody where you're at. It's just a way for me to look out and see what you guys are, to see if there are individuals I need to help, or if I see a bunch of 2s and 1s, maybe I need to come back and revisit something and maybe reteach a little bit. Okay? All right, so go ahead and give me your comfort level. Where do you feel like you're at right now with this? Okay, 3s and 2s. That's good. Okay. Okay, let's go ahead and try these whoa, zoomed way out. Let's try these numbers 5 and 6. Try these number 5 and 6 together with your groups. Go ahead. Okay, guys, you can go ahead and check your answers on the board for number 5. And just because you did not follow the same path I did does not mean you are wrong, right? We can arrive at the same answer in a different way. Generally, what I show you is the most efficient way, but that doesn't make it the only correct way. So on number 5, 2q plus q is 3q, so I combine my terms first. Then I start doing my opposite operation. So I bring variables over to the left, numbers over to the right, divide, and I end up with q equals -4. Any questions there? Okay, number 6. You obviously have to distribute first to get rid of those parentheses. So I distribute the 2 into the first set of parentheses. On the other side of the equal sign, distribute the 4 into the second set of parentheses. And then I start doing my opposites. Again, in the interest of keeping my variables positive, I subtract 8b over to the right-hand side. It doesn't mean you had to do it that way. So since I brought variables to the right-hand side, I bring numbers over to the left-hand side, divide down, and I end up with b equals 4. Okay, any questions on those kind of problems? All right, let's look at special cases. Okay, so these are special for a reason. Weird things are going to happen, but I'm going to trust you guys to try these. So let's go ahead and let's just do 8 and 9. So don't do 10 or 11, just do 8 and 9 together with your groups. Go ahead. Okay, all right, so let's talk about 8 and 9, okay? Guys, how many solutions did all of the ones that we did on the front have? Just one single solution. Okay, so normal problems, when we solve them down, they get x equals a certain number. That's how you know we get one solution. That's a normal problem, okay? Let's look at the weird ones here. So let's look at 8. So I distribute first, right? I get 24s plus 6 times 12 is 72. On the other side of the equal sign, 8 times 3 is 24s. And what's 8 times negative 14? 80, 122, 112. Okay. Okay, I need to do an opposite operation to bring my variables to the same side, so I subtract 24s. What's 24s minus 24s? Gonzo, right? It's gone. It's completely disappeared. So I have 72 equals. On that side, 24 minus 24 eliminates. I get 72 equals negative 112, okay? So anytime we have something that looks like this, okay, when we are having variables completely eliminate, that's when we know we're having a special case, okay? And the only question you have to ask yourself is it true? So does 72 equal negative 112?
Nope.
It doesn't. So since it does not equal, that would be a case of no. That's an ugly N. There you go. No solution. Okay? So if it's not true, once the variables eliminate, that is no solution. Let's look at 19. Is there anything we can do to simplify the left-hand side on 19? Or excuse me, on number 9? No, there's not. So I leave the 16f plus 24 alone. On the other side, 8 times 2f is 16f. 8 times 3 is plus 24. And now I can go ahead and do my opposite. So I subtract 16f for both sides. So that's gone, and that's gone. I'm left with 24 equals 24. Is that true? Yes, yes it is. So this is called infinitely many solutions. You could also say all real numbers for that. Basically what this is telling us, guys, is on number 8, any number you could imagine to put in for S would not make the equation true. There's absolutely nothing that I could plug in for S that would make that equation true. That's what no solution means. On number 9, infinitely many solutions means absolutely any number I could think of. If I plugged it in for F, the equation would be true. Anything.